Let us see how to load the structure. We will go to the loading tab for that, and we will begin with the self-weight. In MIDAS nGen, the loads are put under load sets. Automatically, static load set 1 will be generated if we use this self-weight command. However, let us have our own load set names. So we will click on this 3-dotted box and create a load set for dead load and another one for live load. Note that the load type is very important. Depending on this load type, the program will automatically generate the load combinations. Right now, we only need to create the dead load and live load sets. So the dead load set is chosen here right now. -1 scale factor in the Z direction is by default provided. All we need to do now is click on OK. The self-weight has been applied to the structure, and we can confirm that by going to the Analysis tree menu. Expand the static load, dead load, DL load set, and there we have the self-weight. We can see the scale factor right over here. Next, let us go ahead and apply slab load. In MIDAS nGen, you can apply the dead load and live load on the slabs at once. All we need to do is create slab load type. We can have n number of slab load types. A typical type of slab load can be generated by selecting load sets for dead load and live load and providing the load values. The unit right now is kept as Newton per meter square. However, we can modify that. We can change it to kilonewton meter at any point of time. Let us provide a dead load for the floor finishes of 1.5. Note that a negative sign has been also provided, and a live load of -2. We'll click on Add and Close. Now let us apply this typical type of slab load on the selected slabs. So we will go to the slab load and select all the slabs and click on OK. As you can see, the slab load distribution is two-way. This is depending on the member that we have created. If we want to change, for example, over here, this slab into a one-way type of a slab, all we need to do is select all these slabs from top to the bottom floor by going to the top view and making a box like this for selection, that is from right to left. Then we can see here, this is the information about all those members that we have selected, and we can just simply change the load distribution from two-way to one-way. We can see the direction of this one-way from here. If it's not what we want, we can change the loading direction from 0 to 90 degrees. To unselect the member, we can press Escape. To undisplay all the loads applied, we can simply uncheck these boxes. After the slab load, let us go ahead and see how to apply the lateral loads. In this video, we are going to be including wind load as per BS 6399, static seismic load as per Eurocode 8, and notional load as per BS 8110. Let us start with the application of wind load. We can assign wind load on different types of structures: enclosed area, open area, on equipment type of structure, or just as what we have, the story-based type of structure. that is have none eccentricity. If you would like to include the eccentricity, you can make it positive or negative. And for the percentage of eccentricity, which is usually 15%, it's automatically taken by the program. However, you can modify that. Next, let us define the design wind load. We can click on this toggle box to open the dialog box for defining the design function, add. And from here we can select the appropriate code. So there is Eurocode as well as British Standard. We can select BS6399. The average roof height of the structure that we have already modeled is automatically taken. The site category can be chosen, building type factor, basic wind speed, height of the other buildings, let's say 30 meters, separation of our building with the other, let's say 10 meters, and closest distance to the sea, let's say 1 kilometer. And we can click on OK and close. After that, we can see over here there is generate load set for ortho. If this option is checked on, then wind load in both the directions, that is X as well as Y, will be applied. Do not need to again create the Y direction wind load. We can click on the show profile to see the forces generated by wind load before analysis. We can export this information into Excel sheet. These graphs can also be utilized for the report generation. Click on Add over here for additional loads. If you're using another code, then you provide all the information for all the floors and change the scale factor to 0. If we make this 0, it will ignore the design wind load that we have defined as per the code. By clicking on OK, we can see here these are the arrows which indicate that wind load in X and Y direction have been applied. We can confirm that from the analysis tree menu as well. Wind load set 1 and wind load set ortho. Similarly, static seismic load can be applied. We're going to be applying it on the building structure. We do have the option to apply seismic load on general structure. Here, again, we will check on the box to generate load set for ortho. We'll have 0 eccentricity and define the design function. As per the Eurocode, provide all the parameters as per the site conditions and also the approximate period. So this approximate period can be manually calculated and applied, or you can click on this box, select the appropriate formula, click on calculate and click on OK to use that approximate period automatically calculated by the program. You can perform eigenvalue analysis and get the analytical period as well. You can click on OK, close, provide a scale factor for the orthogonal direction and click on OK. So now we are having 2 earthquake load cases, one in the X direction and the other one in the Y direction. These red arrows are the ones that indicate that seismic load has been applied. Now let us see how to apply the notional loads. So as per the Eurocode, there is imperfection, and as per the British Standard, it is notional loads. So there is an option here to define the initial sway coefficient using user-defined option. The program, in case of Eurocode, automatically calculates the coefficient, and as per the British Standard, we have to provide the value, which is 0.015. So in the major as well as in the orthogonal direction, we can copy these two values by pressing Ctrl C, selecting the rest of the cells and saying Ctrl V. Then we will assign the imperfection to the gravity loads, the dead loads. So we will select the dead load, add, and click on OK.